Hello all, I Priyanka Vijayvargiya from Department of Computer Science and Engineering, Institute of Engineering and Science, IPS Academy, Indore. My specialization in operating system, database management system, computer organization and architecture. So here I am covering one of the topic of COA, that is addressing mode. So we have to know before addressing mode what is the instruction format. So I am giving a basic idea of instruction format. Basically an instruction is divided into three parts, that is opcode, mode and address. Here opcode is operation code. What operation we have to perform on data. Address part gives the address of data. Address of data. Data either resides in memory or registers. And mode field. So what is the mode field? So here we have to perform an operation which we will perform on data stored in that address, given in address field of the instruction. Then how we will interpret that address, it is given by mode field. So address, how we will interpret that address? So mode field is also called addressing modes. It gives us addressing modes. Either we have to interpret that address direct or indirect, or we have to calculate that address. So how we will interpret that address field, it gives in the mode field, and modes are of different types. So addressing mode is basically how we will interpret that addressing field so that we can reach the actual data on which we have to perform that operation code. So now what is the type of addressing modes? There are different types of addressing modes. So what are the types of addressing modes? So first type of addressing mode is implied mode. So what is implied mode? Implied mode tells that the operands or the address is implicitly defined in the address of the instruction. Address is implicitly defined in the instruction. So what are the examples of this mode? Examples are all the instructions which uses accumulator are in the implied mode. Suppose I write complement and no address is given here. So by default the content of accumulator are complemented by this instruction. So it is in implied mode. All the instructions in stack organization, that is zero address instructions. Zero address instructions are also in implied mode. If I write add and no address is given, then by default this instruction tells to pop two elements from the stack, top of the stack, then adding them and restore the result on the top position of the stack. Now the second mode is immediate mode. Immediate mode means the operand is already given in the instruction itself. No address is given. In place of address, operand is given. So address field contains the data या operand. The third addressing mode is register mode. Register mode tells us the address field. Address field contains the address of register, and this register contains the data. So when we see the address field, it depicts a address which is a processor register address, and this register contains the data where we have to perform the operation. Now the fourth is register indirect mode. Register indirect mode tells us address field contains the address of register. This processor register contains a memory location, and this memory location contains a data. So the operation we have to perform on this data, which is stored in memory location, but address field gives us the address of processor register. This register contains the memory location, and this memory location contains the data on which we have to perform the operation code. Now the next addressing mode is auto increment. Or auto decrement mode. Auto increment or auto decrement mode tells us we have to update this memory location. Either we have to increment or decrement this memory location, and then we have to access the data. Auto increment and auto decrement mode first runs in register indirect mode, then we have to increment or decrement. So always increment is performed after the access of data, after access, and decrement is performed before access. That is, if a location is given in address field defines us the address of register. Register contains a memory location. Memory location contains the data. We have to fetch the data, then increment. If auto decrement mode is there, then address field contains the address of register. Register contains a memory location. We have to decrement the memory location, then access the data. So increment is always after access and decrement is always before accessing the data. Now the next addressing mode. For the next addressing modes, we have to know a term effective address. So what is the effective address? Effective address is always a memory location. It is always a memory location. The data on which we have to perform the operation, the location of that data is called effective address. So the actual data, the address of actual data is called the effective address. So effective address is always a memory location. Now the next addressing mode, we have to calculate the effective addresses. So the sixth addressing mode is direct address mode, and seventh is indirect addressing mode. Now the sixth addressing mode is direct addressing mode. In direct address mode, effective address is, what is effective address? So effective address field gives an address which is a memory location, and this memory location contains the actual data on which we have to perform the operation. So address field, whatever the address field contains, it is called the effective address, because in address field, whatever the value we find, it is a memory location. This memory location contains the actual data on which we have to perform the operation code. The seventh addressing mode is indirect address mode. Indirect address mode. In indirect address mode, the address field contains a memory location. this memory location further contains another memory location, and this memory location contains the data. So we find the data indirectly. Address field contains a value which is a memory location. In this memory location we also find a memory location, another memory location, and on this memory location we find the actual data on which we have to perform the operation code. So the effective address is this memory location. Now the eighth one is relative addressing mode. In relative address mode, effective address is calculated by the value of address field plus the content of program counter. So program counter is a processor register which gives the address of next instruction to be executed. So program counter always contains a value. So program counter will depict which instruction is next to be executed. Value of address part, when we add this value to the program counter, it gives the effective address. So whatever the value comes, it is an effective address on which data contains. So suppose program counter contains the value 820. So 820 it contains, so address field of the instruction. So what address field of the instruction contains? So when we go to this location 820 in a memory, then we find the instruction opcode, mode and address. So opcode, mode and address. This address field value we know when we access this instruction. So when we access this instruction, so initially program counter contains the 820. When we fetch the instruction, it contains operation code, mode and address. So now program counter incremented by 1. When we fetch instruction from memory, always the program counter incremented by 1. So now the program counter's value becomes 821. When we access this instruction, we know the value of address part of the instruction. Suppose address field contains the value 50. So effective address becomes value of address part 50 plus value of program counter 821, that is becomes 871. So effective address is 871. When we go to this location 871, we find the data on which we have to perform the operation. The next is indexed addressing mode. And index addressing mode, effective address is calculated by the value of address part plus value of index register. Index register is denoted by XR, and base register addressing mode. Effective address is calculated by address part plus value of base register. So what is index register and what is base register? Suppose we have a memory locations from 0 to 127 and we have a program of 50 lines 0 to 49. So this program number 1, this program may stored in any locations in memory. Suppose this program is stored from here to here, that is starting from location number 100. So this program is of 50 instructions, so 100 to 149. So instruction number 1 to 49 of program 1 is stored here. So base address is 100. So base register contains the value 100. And suppose the data on which we have to perform the operation, it is stored at location 103. So the difference between 100 and 103 is location 4. 100, 101, 102 and 103. So this 4 is the value of index register. So index register contains the index from base address to the actual data, the address of actual data, and base register contains the base value of program where the program start to store in memory. Now, generally we have to calculate this addressing modes, the value of effective address. Generally we have to calculate the value of effective address in different addressing modes. So now we have a question from which we have to derive the effective address in various addressing modes. So now we have to solve a numerical in which we have to calculate the effective address in different addressing modes. Here we have a numerical. If an instruction is stored at location 300 with its address field at location 301, the address field has the value 400 and processor register R1 contains 200, index register contains 200. Then we have to evaluate the effective address when the addressing mode of the instruction is following, that is direct address, immediate, indirect, relative, index, register direct, register indirect, auto increment and auto decrement. So how we will calculate the effective address in different addressing mode? For this we have to maintain a memory stack here. It is a memory stack. So the first line of our question is if an instruction is stored at location 300. So somehow here is 300 and next instruction, next line is with its address field at location 301. So 301. So address instruction contains the three parts: opcode, mode and address. So opcode, mode and address. Here is address field. So an instruction is stored at location 300 with its address field at location 301. The address field contains the value 400. So address field has the value 400. The processor register R1. The processor register R1 contains 200 and index register XR has the value 200. So we have to evaluate the effective address in following addressing modes. So we have to evaluate it in a tabular format. Here is the addressing mode. The next is effective address and next is data. What data is present in this effective address? So first is direct address mode. So direct address mode. So as we know, direct address mode, the address field of the instruction contains a value. When we go to this value, we evaluate the data, we find the data. So in address field, here address field contains the 400. When we go to this 400 location, we find the data on which the operation we will have to perform. This opcode will perform on this data which is stored in location 400. So the actual data, the address of the actual data is called the effective address. So here is actual data is this. So the address of actual data is 400. So effective address is 400 and data. We have to assume the data because we need this value in further modes. So suppose we assume that the 400 location contains the value 800. So data is 800 here for direct address mode. So in direct address mode, address field directly gives the address of the actual data. So this address is called effective address. Then immediate operand. Immediate operand mode. As we know, immediate operand tells us the address field contains the data on which we have to perform the operation. So data is 400 and the address of this 400 is 301. So effective address is 301 and data is 400. Now the next is indirect address mode. Indirect address mode tells us the address field. The address field gives us a memory location, and this memory location gives us another memory location, and this memory location gives us data. So address field contains the value 400. This 400 gives us another value 800. When we go there 800, then 800 contains a value. Suppose 800 contains, suppose 500. So when we go to this value 800, then we find the data on which we have to perform the operation. So indirect address mode tells us the address field gives a value which is an indirect address. So when we go to this value 400, it gives us another value 800, and this 800 gives us the data on which we have to perform the operation. So here effective address is 800 and data is 500. Then next is relative addressing mode. Relative addressing mode tells us effective address is calculated by adding the content of address part plus value of program counter. So value of program counter, initially program counter contains the value 300 because program counter has a function that it depicts the address of next instruction which we will have to execute. So initially it is 300. When we fetch the upcode and mode, when we fetch this instruction, it becomes 301. When we fetch this address field, then it becomes 302. So when we fetch address field, then we know the value of address field is 400. The value of address part is 400 plus value of program counter. Now the program counter's value becomes 302. So we have to add this 302. So it becomes 702. The effective address is 702, and suppose the 702 contains the value 650. So the data is 650 on which we have to perform the operation, and its effective address is 702. Index register address mode tells us we have to calculate the effective address by adding address part, value of address part plus value of index register. So value of address part is 400 and value of index register is 200, that is 600. So 600 is effective address. Now we assume that 600 contains a data. Suppose 600 contains data 900. So 900 becomes data and its effective address is 600. Then register direct mode tells us the address part. Address part contains the address of register, and this register contains the data. So address part, value of address part is 400. This 400 tells us it is the address of, this 400 is the address of this register, and here register is R1 whose value is 200, which is given in this question. So R1 contains the value 200, so 200 is a data on which we have to perform the operation, but the memory location or memory address of this 200 is the effective address, but 200 is stored in register R1, that is processor register, so it does not have any memory location, so we don't have to calculate here the effective address. 200 don't have any effective address or any memory location because it is stored in the processor register. So here we are not able to calculate the effective address. Next is register indirect mode. Register indirect mode tells us address part of the instruction contains a register address. Register address जो है register address, it contains the memory location and memory location contains a data. So address part contains the 400. 400 is the address of register R1. R1 contains 200. 200 is a memory location which contains a data. So suppose here is a 200. 200 contains a data, and suppose 200 contains 910. So 200 is the effective address in register indirect mode and 910 is data. Now the next is auto increment and auto decrement mode. Auto increment and auto decrement mode firstly execute in register indirect mode, then the location is incremented or decremented. So increment always happens after accessing the data and decrement always happens before accessing the data. So auto increment mode automatically covers the register indirect mode. That means address part contains a address of any register. Here is the address of R1. Then R1 contains a memory location, that is 200, and 200 contains the data. So auto increment mode, effective address is 200 and data is 910. After that it is incremented by 201. So increment is happen after accessing the data. So first we will have to access data from this 200 memory location, then it is incremented by 1. Now the next is auto decrement mode. Auto decrement mode covers the register indirect mode, that is address part contains the address of register. This register contains the address of memory location and memory location gives us the data. So here address part is 400. 400 is the address of register, that is R1. The data, 200 is a memory location and this memory location contains the data. So 200 contains the data, but it is executed in auto decrement mode. So we will have to decrement by 1 before accessing the data, so it becomes 199. So effective address is 199 and whatever the value is stored in location 199. Suppose 199 contains 210 value, so the data is 210. So when the instruction is executed in this different types of addressing mode, the effective address changes. The effective address contains the actual data from which on which we have to perform the operations. So here I covered in this lecture the different types of addressing mode and a question based on this addressing modes. So now we are able to calculate the effective address in different types of addressing modes. Thank you.